Hello there and welcome back to this video series on control systems. In the previous video, we have seen what we mean by signal flow graph, Mason's gain formula, and we have also seen that once the signal flow graph is drawn, finding the transfer function between any variable and any output node and input node is simply a matter of identifying loops and forward paths. Just as in the case of the previous videos, after watching this video, you'll be able to apply Mason's gain formula between an input node and an output node to find the total gain or total transfer function. I would strongly urge you to go back and watch these videos once again, take notes, and then come back to watch this video. That way you will be able to make the most out of it. We will see one example as shown here. We are required to find the gain C by R from this block diagram, from this signal flow graph. It's a very simple graph. It has 1, 2, 3, 4 nodes, that is 4 variables, one forward path going from R to C. You can see that R is the input node, C is the output node, going from R to C, and only one loop, E, Y, back to E. We are required to find the transfer function C by R. Let us try to do that. There is only one forward path, as we have already noted, going from R to E, 1, E to Y, G, then Y to C, 1. 3 gains are there, 1, G, 1. So the gain of the forward path P1 is G. And there is only one loop. Okay? There is only one loop. Okay? To identify whether loops are connected or not, we have shown the forward path here. This is the forward path. There is only one forward path. So we say n is equal to 1. Then there is only one loop going from E to Y, coming back to E. So this loop gain is, one factor is G, another is minus H. If you multiply them, it is minus GH. You can see that this forward path P1 and the loop L1 are touching because E and Y are the common nodes. Going from R to E to Y to C is the forward path. E to Y back to E is the loop. So these two are touching each other. Okay, I have drawn it for continuity's sake here. So your delta H is, because there is only one loop, you have 1 minus L1. So this delta is 1 plus GH. Out of this 1 plus GH, if you remove all the terms coming from touching loops, that is forward path and the loop, because all are touching, only one remains. Okay, since P1 and L1 are touching, remove the contribution from L1 to get delta 1 is equal to 1. Hence, by using Mason's gain formula, you have the total transfer function given by this. We will see one more example on using this Mason's gain formula through this example. Okay, this is the signal flow graph given. Okay, and you can see that again in this case there is only one forward path going from R to C. You can go in only one way. That is R to X1, X1 to X2, X2 to X3, X3 to Y, Y to C. If you multiply the gains while you go across all these nodes, you have 1, G1, G2, G3 and 1. So the gain P1 is G1, G2, G3. Also we can see that since there is only one forward path, n is equal to 1. Okay. Now we come back to this and we represent P1 here. Okay, I'm kind of trying to blink it to show you that all the loops touch this P1. Let us identify loop 1. Loop 1 is going from x1 to x2, coming back to x1. You can see that this green is touching red. Okay, so its gain is G1 minus H1 minus GH. Similarly, you have second loop. Second loop starting here x1, x2, x3 back to x1 shown in blue. Okay, its gain is G1, G2 minus H2. So minus G1, G2, H2. Again you see that this blue loop is also touching the blinking red forward path. Then we show loop 3. Loop 3 is going from x2, x3, y back to x2. Okay, its gain is G2, G3 minus H3. Okay, so delta is, because all the three loops are touching, you don't have a pair of non-touching loops. So you have delta is 1 plus G1 H1, because you have 1 minus L1 minus L2 minus L3. You have 1 plus G1 H1 plus G1 G2 H1 plus G2 G3 H3. From these terms, if you remove the terms coming from loops, because all the three loops are touching the forward path, you need to remove contribution of L1, L2, L3. If you remove all those from delta, you are left with delta 1 is equal to 1. So your C by R is P1 delta 1 by delta, which is given over here. You can see how simply we could find this transfer function. If we were to do by block diagram reduction, it would take tons of more time than this. I think that's all we have in this video. Mason's gain formula is seen as an elegant tool to find the gain or transfer function, and we presented two examples. I would strongly urge you to watch this slide and previous two slides again to get a good practice of Mason's gain formula. I think that's all we have for now. Have a great day.